Alright, we're going to continue with integration by substitution. You should not even begin this lesson unless you've worked on the last homework assignment, because it's just continuing on, except we're going to have trig functions in there. It's very important that you have done most, if not all, of the other assignment before starting working on this one. In this example, what we have is typically we're looking for where those parentheses are. Well, there's no parentheses here. We just have to recognize the parentheses as being after the sign. So if we have one trig function, typically we're going to pick what's after the sine, cosine, tangent, whatever happens to be there. So I'm going to go ahead and pick my u to be x to the fourth, which makes my du be 4x cubed dx. So I'm going to be able to rewrite this as the sine of u, and I need exactly a 4x to the third dx, which is what I have, and I'll just write a du here. So when I integrate this, I end up getting negative cosine u plus c. So this ends up being my final answer. Next example, we have the same type of scenario. We're going to go ahead and pick what's after the sine to be our u. So our du is 2x dx. So the difference in this problem is that I only needed, when I rewrite this, the sine of u, I only need an x dx. So that's right here. So I'm going to move my 2 to the other side. So that means if I replace the x dx, I need to replace it with a 1/2 du. So now when I integrate sine of u, I get negative cosine of u plus c, and then I'll just distribute my 1/2 through for my final answer. In my next example, I have two trig functions, but this isn't one where I need to think about choosing one of my u's to be an actual trig function, because I know what the integral of sine of u, tangent of u would be. So I'm going to pick my u to be 1 minus x, which makes my du be negative dx. So when I rewrite this, I get secant u, tangent u, and I need only the dx part. So I'm going to say that dx is equal to a negative du. So I'll put a negative du to replace my dx, and then I'll integrate. Well, the integral of secant tangent is secant, and then I'll have my plus c, and I'll replace my u value with my x. And I just realized I did not do that on the last examples. So I'll go back up and make both of these. I should have replaced my x values. So that is to my x values. That's completely my fault. And this is my final answer. So I need to get rid of that part. And this one right here, again, we needed to replace it so that was in terms of x. So this right here would be my final answer. I'm sorry about those. That's one. Go back and put those x's in. I just showed that. On this one, we have two trig functions, and I don't know the derivative or the integral of tangent x, secant squared x. So I want to think about which one would I pick to be u, so that when I took its derivative, it would go away. And that answer, that would be tangent of x. So if I take the derivative of tangent x, I get secant squared x dx. So that's going to let me be able to rewrite this as the square root of u, so that takes care of this part, and then I need secant squared x dx, which is exactly what I have by putting a du here. So now I have the integral of u to the 1/2 du. So I'll raise this by 1 and put it over that power, and I'll have plus c. So I end up getting 2/3 u to the 3/2 plus c. So that gives me my final answer once I plug back those x values. I won't forget that again. Of tangent x to the 3/2 plus c. Alright, for my next example, I've got sines and cosines. Now if I look at this a little bit more closely, this really says sine of x over cosine x cubed. Now that's a big difference, because if I pick sine to be my u, I'm going to have a hard time getting rid of 3 of these cosines, because that's really what I have, cosine x times cosine x times cosine x. So I really want to pick my u to be what's on the bottom there, cosine of x. When I take its derivative, I get negative sine x dx. So that means I'll be able to rewrite this as u cubed on the bottom. I need a sine x dx. So I only want this portion, so I'm going to move my negative to the other side. So now I can replace my sine x dx with a negative du. So this really says u to the negative third. And now I'll integrate that by raising it by 1 and putting it over that power plus c. So it really gives me a 1/2 u squared on the bottom plus c. And then I'll finish this off by replacing it in terms of x. So I can write 1 over 2 cosine squared x plus c. My next example, if I go ahead and pick what I normally would pick for my u, I would pick what's in the parentheses, which would be the 4x plus 1. The problem with this is when I go to take the derivative of it, I get 4 dx. Now, what's the problem with that? Well, try to start substituting this back in. You have a square root of u, you need an x dx. Well, that's a problem. You didn't get an x dx, you get a 4 dx. So this is where we have to go a tiny bit further. In order to get that x and replace that x, I'm going to go ahead and get rid of this part. We'll end up putting it back in. I know I need an x dx. Well, I need to figure out what x is equal to in terms of u. So what I'll go ahead and do is subtract 1 on both sides. So I get 4x, I subtract 1 on both sides, is equal to u minus 1. And then I'll divide by 4, which gives me u minus 1 over 4. So, what does this do for me? Well, let me show you. I can now replace this part like I just had done and I erased with the square root of u. I can replace x with a u minus 1 over 4. Even though that doesn't look pretty, I can do that. And then I just need a dx, and I can get the dx from this other portion, which I would move my 4 to the other side and get 1/4 du. So I'll put a 1/4 du in here. Now before I would integrate this, I definitely want to simplify it. So as I look at simplifying this, I notice I have this 4 right here, which would pull out and be 1/16. And then I'd have the integral of u minus 1 times u to the 1/2. So I'm going to now be able to distribute this, and I get u to the 3/2 minus u to the 1/2 du. So now I'm ready to take the integral, which will give me u to the 5/2 over 5/2 minus u to the 3/2 over 3/2 plus c. It looks like a mess right now. So what we're going to do is we're going to simplify this a little bit. And I'll come up here with that. I'll have 1 over 16. This would be 2/5 u to the 5/2 minus 2/3 u to the 3/2 plus c. I need to replace my u values with x's. So I get 1 over 16. And actually, let's go ahead and distribute the 1 over 16 through as I'm replacing my x's. So this would give me 2 over 80, which would be 1 over 40. And then I'm going to replace my u with the 4x plus 1 to the 5/2. Minus distribute that through, you get 2 over 48, which reduces to be 1 over 24. Replace your u with the x's. And then you put plus c. Alright, this next one, what we're going to do is we're going to evaluate this integral. So, once again, this is going to be one that turns out a little bit more difficult, because if we choose what we normally would choose, which is fine, we want to do that, it doesn't allow me to get this 2x plus 1. So what I'm going to have to do is I'm going to need to figure out, well, what is x equal to? And x is equal to u minus 4. So I'm going to need to rewrite this. And I'm going to have to rewrite this as 2. I'm going to keep the 2, replace my x with a u minus 4 plus 1 over, I made my u be square root of this x plus 4, so square root of u. And then my du and my dx can be interchanged because they're equal to each other. So now I hopefully will be able to integrate this, but I'm going to need to simplify this first. So I end up with 2u minus 8 plus 1 all over u to the negative first. I'm going to continue to simplify this. So I've got 2u, this would be minus 7 over u to the 1/2 du. I'm going to simplify it one more time by dividing each of these by u to the 1/2. So this will give me 2u to the 1/2 minus 7u to the negative 1/2 du. So I'll come back up here to go ahead and integrate this. So I'd have 2u to the 3/2 over 3/2 minus 7u to the 1/2 over 1/2 plus c. So that gives me 4/3 u to the 3/2 minus, I'd have 14u to the 1/2 plus c. The last thing I'm going to do is substitute those x's back in. So I've got x plus 4 here, so to the 3/2 minus 14. We can just write square root of x plus 4 plus c. It's no longer a problem. This next one is for a definite integral. So I'm going to show you a little shortcut so we can do definite integrals much more quickly. We are going to change these bounds. So right now we have them in terms of x's. I'm going to pick my u to be what's on the bottom, and hopefully we end up with what we need because it makes things a lot easier. I get a 4x dx, so this seems to work out pretty well. I'm going to leave this integral right now. I'm going to just say this would be the integral of something over square root of u. I need an x dx, so I only need the x dx, so I'm going to move the 4 to the other side. So I put a 1/4 du in here. Now the problem with this and going ahead and integrating this is I want to teach you guys how you can just change your x bounds into u's. So what we're going to do is we're going to take this x bound and plug it in right here so that we can change it into a u. So u would be equal to 1 plus 2 times 0 squared. So that would be 0. 1 plus 0 is 1. So we'll change that bottom bound to be a 1. And now if you change this to be a 2, you now have 2 squared, which is 4 times 2 is 8 plus 1 is 9. So our new bounds are 1 and 9. What that does is it allows me not to have to change this back into x's at the end because I've now changed my bounds to be u's. So I have 1/4, the integral of 1 to 9 u to the negative 1/2 du. Let's go ahead and integrate this then. We get u to the 1/2 over 1/2. And we're not writing plus c because this is a definite integral. So this ends up being 1/2 because 1/4 times 2 would be 1/2. The square root of u from 1 to 9. I'll come up here to finish this. I get 1/2. And then I'm going to plug in 9 first. So I'd have the square root of 9 minus plug in 1, the square root of 1. So I have 1/2 times 3 minus 1, which would be 2. And 2 times 1/2 is 1. Now I am going to have one more example like this, and I'll do that on one more video, so it will be very short. The last one, as well as this one, it did ask me to verify this on a calculator. Please remind me to show you how to use your calculator in class. Again, there's so many different calculators that you guys are using, so it'll be much easier for me to talk about those during class. What we're going to have now is another definite integral. We're going to go ahead and solve for this one. I actually had 2 problems and I realized that just now, so apologize for that. So u equals 2x minus 1. This one again is not as easy just because I don't get what I need. I need an x dx, not a 2 dx. So I'm going to have to take this off to the side and say, well, u plus 1 equals 2x. So x is equal to u plus 1 all over 2. So now I'm going to go ahead and start to rewrite this. So I would have the x part up top as being u plus 1 over 2 all over the square root of u. I only want a dx, so I'm going to have to move my 1/2 to the other side. So I have 1/2 du. This is an absolute mess right now, so we're definitely going to be needing to do some simplifying. So as I look at this, I am going to first rewrite this as 1/2 u plus 1/2 all over u to the 1/2 du. Let's see what this allows me to do. Well, I could actually pull out my 1/2 because there's a 1/2 on each one of these. So I have 1/2, and I'm going to go ahead and rewrite this. 1/2 u plus 1 all over u to the 1/2, just in case you don't see what I'm doing. Now I can pull out my 1/2, which gives me 1/4, and then I can divide each of these off, so I get u to the 1/2 plus u to the negative 1/2. Now I need to also figure out my new bounds. I've left those off, so I'm going to come back up here, plug in my 1. So I have 2 minus 1, which is 1, and then plug in my 5, which will give me 5 times 2 is 9, minus 1 is 8. So I'm going to have my new bounds of 1 to 8. Or I mean 1 to 9, excuse me. That should be 9 because it's 10. So now I'm ready to integrate this, which would give me u to the 3/2, and it'd be over 3/2, which would put a 2/3 out front. I'd have u to the 1/2 over 1/2, which would be 2. And I'd have I don't need plus c because I'm going to be plugging those in. So I end up getting 2/3, 9 to the 3/2 plus 2 square root of 9. Minus, then we'd have the same thing by plugging in 1. Well, that would be 1, so I just have 2/3 plus I'd have 2. And I'm multiplying by 1/4 at the end. So the square root of 9 is 3. 3 squared is 27, so I get 54 over 3 plus 6 minus, this would be 2 and 2/3, which would be 8/3. And we're multiplying by 1/4 at the end. So I end up getting the answer of 18 plus 6 minus 8/3 being multiplied by 1/4. And when you simplify all that, you end up getting 5 and 1/3. And I'm squeezing that in there. My last problem I probably will not be able to finish. I'm not going to make a whole nother video for this. This would be u to the x, or u equals x squared, to make my du be 2 dx. And then I'd replace this with secant, or cosecant u, cotangent u. And then I'd only need a dx, so I'd solve for this, and I'd have 1/2 du equals dx. So I have 1/2 du. Well, I know this, I need to change my bounds. So my bounds would now be pi over 6, and put in pi over 4, I'd get pi over 2. And so when I integrate, I end up getting negative 1/2 cosecant u from pi over 6 to pi over 2. And I will go ahead and tell you what the final answer is, because I will not be able to finish this in this video, but you should get 1/2. If you don't get 1/2, we can discuss that in class.